This is the second part of the test where we compare the SwashPlate movements of three axial piston pumps connected in series. However, this time the axial piston pumps are pressure compensated pumps. There will be two parts of this experiment and we will go one by one for both the parts. In the first part, right now I have set all the pumps to full capacity by making the resistance 0. As you can see, the full flow and there is no pressure on the pumps. Here, an interesting fact can be seen is that all of these three pressure compensators 1, 2 and 3 have been set at 280 bar. This is a simulated environment where all three have been set using the knob at 280. We will now plot the SwashPlate angles for the pumps and check how is the movement of the SwashPlates when the different flow and loads are available. Right now, I am changing the load. As I change the load, you can see because the pressure is set at 280, I have to go above that particular pressure to make a change. And now you can see that plate movement is happening. There is a change in flow. All the three SwashPlates are moving. You can see at this specific position there is a gap. This is, and there will be differences in the movement of the SwashPlates. This is because of the time taken by the spring setting or spring stiffness of different compensators. You can visibly see that there is a difference. However, this is in an ideal condition. In this industry, we will never find an ideal condition like this to do a rapid change. And you can see the behavior in the rapid change. There are rapid fluctuations in the demand system. This is very common in an industrial scenario. Of the experiment, we are going to do the ideal thing. Typically, since this is set through a spring, it is not possible humanly to set it at the same value. This error may depend up to 3 to 4 bars. For this experiment, we will take it at 5 bar. On the left, we are putting this at 275 bar. Here it is 280 and on the rightmost, we will set it to 285 bar. Now, this is more of an ideal approach what you will see in the industry where there will be some differences in the compensator setting. Let us see how the reaction of the system is when there is a differential pressure. As you can see, when the pumps will be taken onto load, right now it is at constant because all three are moving. Now I am increasing the load pattern. As I increase the load pattern, you can see the difference in the movement of the SwashPlates. This is definitely because one of the SwashPlates which is at the lowest will try and move fast as compared to the others. You can see the SwashPlate movements on different scales. If I pause this simulation for a second, you can see here the large variations in the movement of different SwashPlates. At this position, when we had equal, you can see equal 280 bar setting, you can see that most of the curve was ideal. However, at this position, you can see that different pumps are stroking at different values. This is the result of using a, even at a 5 bar difference, you can see that there is a lot of difference in the movement of SwashPlates. This does not create an equal load on the different pumps. As you can see in this pause movement, even at a constant load, this pump, which is set at 275 bar, has a flow where both of them own. Hence, this fluctuation of this pump will be much higher as compared to the others. This is why we recommend the use of remote compensated pumps with a common relief in applications of piston pump in series. Thank you.